Hello, students. Let's practice our for and while statements again, and introduce another one. Let's introduce if. Now, you know if from your comprehensions, but we can have an if statement, just like we can have a for statement outside of comprehension as well. So, for instance, what I could do is I could say if something, and then I could have something happen. For instance, I could say, I don't know, a equals 1. Okay, and because this was true, 4 was less than 5, as long as this item is true, this thing after the indent will happen, and I could ask what a is, and a is 1. If this were false, it would not have given me 1, it would have given me an error, because a would have been undefined. Let's say I now do if 4 is bigger than 5, a is equal to 3. Okay, well, let's see. As I see, a is still 1. That's because it never did the stuff after the indent. And as you could imagine, just like with while, it will do, and for, it'll do everything after the indent. If 4 is greater than, well, let's see, if 4 is less than 5, I don't know, a equals 1, b equals 2, c equals 3. And what happened here, a, b, c, last for it as a triple, as a tuple, which happens to be a triple, 1, 2, 3. So I got that. So it did all of these things after the indent. Anything that I put down here is going to get done no matter what. So what do I mean by that? And what do I mean by down here? Well, over here, d equals 5. So let's see. If I do 4 is greater than 5, and let's change these numbers to something else. And now let's ask what these are. Notice that it did not change a, b, and c to 11, 22, and 33 because 4 is not greater than 5. This is false, so it did not do these things, but it did do this thing. It did that thing because it's not part of the indent. This is the stuff that gets done, this indented part. This is the stuff that gets done if this is true. Okay. So that's basically how an if statement works. Quite often we'll have variables. For instance, we might have an x, and we don't know maybe whether that x is greater than or less than 5 or something like that. So let's think of some examples where we could play around a little bit. Let's try adding up some primes. Add primes up to n. So I want to add all the primes up to n. And you know, it's sort of ambiguous. It's like up to n. Well, would that conclude n? Well, I'm saying it's going to add the ones up to n, so it sounds to me like it'll include it. Okay. So what I want to do here is I want to add up all the prime numbers up to n. Okay. So let's try this in a functional way. No, let's try it in an imperative way first. So what I'm going to do is I'm going to have some total. I start with 0, and now I'm going to sort of build up. So I'm going to set I to be equal to, we can start with an actual prime. I'll give us that extra step. And then I'll say while I is less than or equal to n, what we're going to do is we're going to add it to the total, but only if it's prime, because I want to add all the primes up to n. So what I'll do is I'll say if, now we got double indents going on. If is prime I, total plus equal I. And now I want to return the total. Okay, we got a lot going on here with this double indent stuff going on. And I mean, we have an indent here for the function. That's true. We have an indent here for the while. So whenever we're less than or equal to n, we're going to keep going. And you'll see now I didn't actually make this stop, so I'm going to have to do something about that. But that's actually going to be a nice teaching experience, because where do we increment I? Okay, but in any case, what we're doing is we're checking whether the I is prime. If the I is prime, we're going to add it to our total. Okay, so now what I'm going to have to do is I'm going to have to increase I at some point. And what I'm going to do is I'm going to increase it here. This is why. For each I, we are going to check to see if it's prime. If it is prime, I'm going to increase I. And we're going to keep going up to n. When it's n, we still do the while thing. We still do the business because we can add it if it turns out that n is a prime. And then we're going to return the total. So now let's see if this works for some numbers let's try adding up to 5. Does that give me, and we have to define is prime. So from SIMPy, import is prime. So now that we have that, let us try to add the primes up to 5. And I get 2 plus 3 plus 5. Okay. Now, let's look very carefully. What would happen if I did this? Let's just think about that. You could pause and think about it. Get your answer. Okay. You've had time. So what's going to happen here? Well, notice that it's only going to increment I if I is prime. So the second it hits an I that's not prime, it's going to go to this if statement. It's going to see it's not prime. And it's going to get stuck in this while. And it's going to check again. Hey, is I less than n? Yeah, I didn't change it. And it's going to get stuck here. It's not going to do this thing because it's not prime. Go back to here. Again, check. I hasn't changed. Check the if statement. So we're going to go back and forth forever. So this actually has to be here. What if I put it here? Well, the same problem would happen because I would never get incremented inside the while. This takes place after the whole while loop. So it has to be right there. So getting the right indent is important. What if I did that? I put the return there. Well, this isn't going to give me an infinite loop. Let's try it out. But it isn't going to give me the right answer either. And what happened here? Well, first we checked to see if I is less than or equal to n. It was. Then we said, hey, is it prime? Well, we started off at 2. Hey, it is. Okay, let's increment I. Okay, we're all ready to go. We're going to do 3 next time, but I was told to return before doing anything else, and return leaves the function. Doesn't matter if you're inside a while, which is, inside a for, which is inside a while, which is inside a for, whatever loop you're in, as soon as you hit that return, you are outside the function. So this also has to be there. So indentation is very important, but by using indentation, it sort of makes it clear what's going on. This if, the only thing that happens if that's true is the totaling. This while, regardless of what happens here, this is inside the while, so I is going to get incremented each time before we go back to checking for that while statement here. And this return, it's outside the while and it's outside the if. It happens after everything else is done. And we can see that because Python uses indentation very nicely in order to indicate where the loops are. So this is nice. Let's do this for 100. Boom, we've added the primes up to 100. And let's just do it once functionally. Let's make a second version. So what I'll do here is I'll have it just return. Well, it's going to add. What's it going to add? It's going to add the sum of I for I in range. We could start with 2, just like we did over there. And we go to n plus 1. But we're only adding the ones that are prime. So now let's try this. But we will try version 2. And as you see, we get the same thing. So this is an imperative way of doing it. This is the functional way of doing it. So this way we gave it a set of instructions. This way we sort of just said, hey, this is the sum we want. Add the i's that are prime in this range.